So on this problem here, we are talking about residual plots. So these are all the notes for residual plots. Make sure you have the correct paper out that says residual plot notes and looks similar to this. So a residual tells us how far each data point is from the regression line. We're going to take our residual, and it's equal to the actual minus the estimated or the predicted. A point that's above a line of best fit has a positive residual. The prediction of the line of best fit is too low. And a point of below the line of best fit has a negative residual, and the prediction of the line of best fit is too high. So basically, if you have a positive residual, you're going to see that point on the residual plot above that kind of line, because the line of best fit is below that point. And if you have a residual plot that's negative, you're going to see it kind of appear below the line of best fit because the line of best fit is above it. A residual plot is a graph of all of these residuals and how far away they are from the line of best fit. So let's talk about the two types of residual plots that we see. We see linear relationships and nonlinear relationships. We're really focused on linear relationships this unit. So when we're looking at residual plots, you should see them kind of randomly scattered. So all of the points should be randomly scattered. There's no real pattern. You should also see about the same amount of residuals above and below the axes or the line. So if you look at these examples on our note sheet 1, 2, 3, and 4, there are about similar amounts of points above and below the line. And you'll also know that there's not really a consistent shape to it. Versus on the other side, the nonlinear relationship, there's a very clear pattern for each of them. And I kind of connected some of these patterns to show you. There's an uneven amount of positive and negative. So there's more points either below or above that kind of line. And it's going to be lots of more points above or below. So if you look at this first graph, it kind of makes this like UW shape. That's a clue in that it's nonlinear. Or this second one, the number of apples, where all the points are kind of above our axes or our line of best fit. And then the third graph here, it kind of makes this cone shape. And our fourth graph, although it makes a linear shape, it has a pattern, so it is nonlinear. So you make sure with the residual plots, I know it's kind of tricky, but linear relationships, there's no pattern. So we've got two kind of note examples to go over here. So the first thing I have here is a table. So I've got the number of oranges versus the weight in grams. And we also have our estimate. So this first column is our X values. If you would take your X values and you would plug them into your line of best fit for X, and you would simplify, that gets you your estimate. So basically, like whatever your line of best fit equation is, so Y equals MX plus B, you're taking your X value. So for the first one, we would take 3 and we plug it in for X and we'd simplify it. And this would be our output, 99. So that's how estimate works. The Y value that they already give us is our actual value. So we're going to take our actual and we're going to subtract our estimate or predicted value, and that will give us our residual. So on the first one here, we do 102 minus 99, and our residual here is 3. And then we're just going to go down and use a calculator and do this for everyone. So 116 minus 120 is -4. 150 minus 142 is 8. 161 minus 164 is -3. 176 minus 185 is -9. 211 minus 207 is 4. 223 minus 228 is -5. And 256 minus 250 is 6. So there's all of our residual values. So right away, I'm noticing that we've got 1, 2, 3, 4 of them that are positive, 1, 2, 3, 4 of them that are negative. So we've got a similar amount of positive and negative residuals. And all of these are fairly small. They're less than 10. They're not huge. So they're fairly small and close to 0. So part A is we just filled in the table, which is what we were supposed to do. And part B here says, is the linear model given a reasonably good fit? Explain. So what we just talked about, there's a similar amount of positive and negative residuals, and most of our residuals are close to 0. So yes, this is a good fit. Now let's look at our second problem here. So we've got a local restaurant manager created a scatter plot to display the relationship between the percentage of the bill left as a tip Y and the total bill in dollars X. The scatter plot and line of best fit are displayed in the graph. So here's our line of best fit. That's going to be our estimated values. All the points on that line are the estimated values. And all of the data points that we can see, those are our actual values. So when we find these next couple parts, we're going to take our actual and we're going to subtract our estimated. So first thing we're going to do here is we're going to do the total bill of $3. So we're going to go to $3 and we're going to put a point at our estimated, which our Y value here would be about 26. And that's our estimate. And then we're going to go up to our actual, which is at 30. And we're going to take our actual and we're going to subtract our estimates. We're going to do 30 minus 26, which gives us 4. So our residual is 4 there. Now we're going to do the same thing for $27. So $27, here's our actual, which is at 6. And then our estimated here would be at 10. So we're going to do 6 minus 10, which is -4. And that's our residual. And one more time here with 18. So let's go to 18. Here is our estimated. Okay. And that is, I don't know, 16. And the actual, we're just going to pick the one closest to it, which is right here. That is, I don't know, 17 about. So 17 is actual, 16 is estimated. So this would give us about 1. Okay, so part D here says, which two bills have the smallest residuals? Explain. So we're looking at our line of best fit, and we're actually looking for that are the closest to the line. We're basically on top of the line. So let's go ahead and do that. So if you're looking at your line here, I see a point right here, and I guess kind of marked it in blue, and it is at a total bill of about, I don't know, 13, it looks like. So it's going to have basically a residual of 0, as well as this other one that I'm marking in blue right here. And that total bill looks to be about 21, maybe $21, $22, somewhere in there. And again, my explanation here is going to be that these are the closest to the line of best fit. Now it says which two bills have the largest residuals. So do you want these that are the farthest away from your line of best fit? So right here at 3, that's actually a pretty big gap that we used on our first one. I'm going to kind of circle it in purple. You'll see that that's pretty spaced out. That's pretty, 4 spaces is pretty far for at least this graph. So that would be one, the total bill of $3, as well as this right here. This residual is pretty far away from the line. Looks like to be at about $10 as the bill. This also looks pretty far away. It looks like it's at about 15, and the line is, I don't know, 20. So that's pretty spaced out there. And then the last question here is the linear model a reasonably good fit? So most of the points are pretty close to our line of best fit. It looks like the residuals are fairly small. So yes, this is still going to be a good linear model. Same or a good fit, same for what we said on below. So all of our data points are pretty close to our line of best fit. So that would be part of your explanation. And that there seems to be a similar amount above and below the line of best fit. So same explanation kind of as the first question. All right, we're going to go on to our causation notes next.